This is section 8.1, polar coordinates. And we're going to begin with plotting points using polar coordinates. Now, a polar coordinate system consists of a fixed point O called the pole or the origin, and a ray called the polar axis with an endpoint at the pole. Each point P in the plane is defined by an ordered pair. Now, our ordered pair in polar coordinates gives us R, which is the distance from the pole to the point P, and theta is the angle, directed angle, from the polar axis to the line OP. So we have a few things to talk about with regards to R. If R is positive, the point is located R units from the pole in the direction of theta. But if R is negative, we will have that magnitude, that absolute value of R units from the pole in the direction of theta plus pi, which is the opposite of theta. Now, if R is equal to 0, our point is located at the pole. Of course, our directed angle theta, we will be counterclockwise if that angle is positive, and we will be clockwise if our angle is negative. Okay? So let's just plot a few points and see how we do here. We're going to begin with point A. As you can see, we are 3 units, which is R, and angle pi over 4. So let's plot that point. So we're pi over 4, and we have 3. I think I did 4. And that is point A. Point B, we are at pi over 6 for our directed angle. However, we will go away from the pole 4 units. So even though we're here at pi over 6, we're now going to go the other way, and that's 4 units. So that will be 1, 2, 3, 4. And as you can see, this is B. Whoops. Okay, so keep in mind that negative. Okay, and I mentioned it up here. We will go in the other direction, or theta plus pi, opposite of theta. That's negative. Okay, now C, we are going to have negative 4 pi over 3. So as you can see, we will come around this way 4 pi over 3, and then 2.5 is R. So we'd be approximately right here. Oops, I didn't go all the way up. 2.5 would be right here. And that is point C. Okay, so there was an example with moving clockwise with our angle. Let's go to 9 pi over 4 for point D. Now remember, 8 pi over 4 is a full rotation. So we are now going to go pi over 4, and we're on the same at the same place as point A, but now we will come out to R equal 5. Okay, so remember we had to come around and go to this point. Okay, E, 7 pi over 6. So we are going to come around like this, and we are going to go to 7 pi over 6, and that would be 6 units, which would be right here. And let me erase this. And as you can see, this is point E. Point F, we are 5 pi over 6. So as you can see, we're right here. However, we have negative 5. So we will go across the pole to 1, 2, 3, 4, 5 right here. And that is point F. Okay. So now let's take a look at the ordered pairs r theta and then r theta plus 2n pi for any integer n. Keep in mind that these represent the same point. So there are infinitely many ordered pairs for the same point in polar coordinates. Okay, so now let's look at number 2. Given the point 3, 7 pi over 6, find 2 other polar coordinate representations with r being positive. Again, your answers may vary. However, let's go ahead and have 7 pi over 6 plus 2 pi. And of course, that's equal to 7 pi over 6 plus 12 pi over 6. And we come up with 19 pi over 6. And that ordered pair would be 3, which is our r, 19 pi over 6 as our theta. Let's come up with another one. We have 7 pi over 6. And this time, let's subtract 2 pi. And that's equal to 7 pi over 6 minus 12 pi over 6. And that gives us negative 5 pi over 6. So our ordered pair is 3, negative 5 pi over 6. And again, that is just this single point right here. Okay, the ordered pairs, and let me highlight this, the same point. The ordered pairs r theta and negative r theta plus 2n plus 1 pi represent the same point. So this represents a plus or minus odd multiple of pi. And this is an angle with a terminal side in the opposite direction of theta. So given the point 2 pi over 3, find 2 other polar coordinate representations with r less than 0. So we have pi over 3 plus pi, and we have pi over 3 minus pi. And of course, we come up with 4 pi over 3 and negative 2 pi over 3. Oops, and that should be a negative. So here, r is negative, and as you can see, this point will be right here. And so both of these represent that same point. Okay, convert ordered pairs between polar and rectangular coordinates. So in order to convert polar coordinates to rectangular coordinates, we are going to use that x equals r cosine of theta and y equals r sine of theta. If we are going to convert, so polar to rectangular, we'll use that. Rectangular to polar, we will use r squared equals x squared plus y squared, and also the tan of theta is y over x. So let's first, in number 4, convert the ordered pair in polar coordinates to rectangular coordinates. So I always like to plot this point first. So if we have 3, 5 pi over 3, we are right here. And now, let's go ahead. We have that x is equal to 5 cosine of, 3 cosine of 5 pi over 3. And that is equal to 3 multiplied by 1/2. And that's 3/2. We have y is equal to 3 sine of 5 pi over 3, and that's equal to 3 multiplied by the opposite of root 3 over 2, and we come up with the opposite of 3 root 3 all over 2. We are in quadrant 4 here. And so we have 3/2, the opposite of root 3 root 3 over 2. Okay, let's look at number 5. 5, the opposite of pi over 4. So let's plot that point first, and as you can see, we're going to be right here. And let me not write over that 7 pi over 4 notation, okay? So now we have x is equal to 5 cosine of the opposite of pi over 4, and that's equal to 5 root 2 over 2, and here we are again in quadrant 4. Let me move this. And then we have 5 root 2 over 2. And now we have y is equal to 5 sine of the opposite of pi over 4, and we have 5 multiplied by the opposite of root 2 over 2, and we get the opposite of 5 root 2 all over 2. So our rectangular coordinates are 5 root 2 all over 2, and the opposite of 5 root 2 over 2. Okay. Now let's go the other way. We are going to convert the ordered pair given in rectangular coordinates to polar coordinates. And here we were going from polar to rectangular. Okay, again, keep in mind we'll have positive r and theta between 0 and 2 pi. So let's use the r squared equals the opposite of 3 root 2 squared plus 3 root 2 squared. And as you can see also, I guess I could put it right. I'll draw it when we get down there. And then so we have r squared is equal to 36. So r is equal to plus or minus 6. Of course, we're going to just use a positive 6 since that's what they've asked us. So now we'll have the tangent of theta is 3 root 2 over the opposite of 3 root 2, and that's equal to negative 1. So theta must be equal to 3 pi over 4. So as you can see here, we are going to be in quadrant 2. And now our polar coordinates are 6, 3 pi over 4. Okay, let's take a look at this next one. 2, negative 4. So we have r squared equals 2 squared plus negative 4 squared. So we have r squared equals 20, and r equals plus or minus 2 root 5. And we will use r equal to the positive 2 root 5. So we have the tangent of theta is the opposite of 4 over 2, which is equal to negative 2. So theta is the tangent inverse of negative 2. And remember, we're in quadrant, let's take a look here. We are in quadrant 4 because we're 2, negative 4. Should have put this quadrant 2, quadrant 4. So we have 2 root 5. And then we're going to add 2 pi to the tangent inverse of negative 2. So in quadrant 4, we're going to have to add 2 pi to that, because in quadrant 4, we will have to have okay. Now let's convert. I'll square that off. Now we're going to convert between equations in polar and rectangular coordinates. So now we are going to be working with equations. So how are we going to do that? If we're going to convert from rectangular to polar, we're going to use x equals r cosine theta and y equals r sine theta. And if we're going to convert from polar to rectangular, we're going to use one of these strategies. One or more. Okay, so let's go ahead and give this a try. We're going to write an equivalent equation using polar coordinates. So what we have is x equal to 12. So we have r cosine of theta. That's what x is equal to. So what does that mean? That means r equals r cosine of theta equals 12. And so r would equal 12 divided by the cosine of theta, which is equal to 12 secant of theta. Okay, in number 9, we have y equals negative 6. And we know that y equals r sine of theta. So r sine of theta equals negative 6. So r is equal to negative 6 divided by the sine of theta. And so r is equal to negative 6 cosecant of theta. And I think I want to bring this up just a bit, maybe more like that. Okay, now let's look at number 10. 2x minus 5y equals 4. So we're going to substitute x and y into the equation. So we're going to have 2 times r cosine of theta minus 5 multiplied by r sine of theta is equal to 4. So factoring out an r, we have a 2 cosine theta minus 5 sine of theta, and now we can solve for r. Okay. How about number 11? X squared plus y squared equals 121. Well, as you can see, x squared plus y squared is equal to r squared. So r must be equal to 11. Remember that r is going to be the square root of r squared. Okay. Number 12, x is equal to 4y squared. So let's go ahead and plug in what we know. We know that r cosine of theta is equal to 4r sine of theta squared. So now if we divide both sides by r, we are left with the cosine of theta is equal to 4r sine of theta. So now let's divide both sides by 4. And so we have, this should be sine squared. So now we see that r is equal to the cosine of theta divided by 4 sine squared of theta. Okay, and so now you can see that that is just 1/4, and we can break this up into the cosine of theta over the sine of theta, 1 divided by the sine of theta, just to give us a little help with our trig functions. So that'd be 1/4 cotangent of theta, cosecant of theta. So some of these can be a little tricky, but I think if you take your time, you should be okay. And one thing, did you see how we could divide both sides by r? Keep in mind that r is not equal to 0, so it is okay if we divide both sides by r. Okay, in number 13, we have x minus 5 squared plus y squared equals 25. So writing this out, x minus 5 would be r cosine of theta minus 5 squared plus r sine of theta squared equals 25. So we could go ahead and multiply this out. R squared cosine squared theta minus 10r cosine of theta plus 25 plus r squared sine squared theta equals 25. So our 25s can cancel. I think this is a nice color. And then we can see that we have r squared cosine squared and r squared sine squared. And so that is just equal to, if you go ahead and write that out, r squared cosine squared theta plus sine squared theta. This is just equal to 1. And then we still have minus 10r cosine of theta. Let me write that a little neater. Is equal to 0. Okay? So this is just r squared minus 10r cosine of theta is equal to 0. We could factor out an r minus 10 cosine of theta is equal to 0. So solving this, either r is equal to 0 or r minus 10 cosine of theta is equal to 0. So let's go ahead over here and solve both of those. Either r is equal to 0 or r minus 10 cosine of theta equals 0. So we can say that r is equal to 10 cosine of theta. Now, this r equal to 0 is also included in this solution here, because this is, let me just make that note. Okay, now let's convert the polar equation to rectangular form and see if we can identify the type of curve represented when we see our rectangular form. Do we recognize the curve? Let's see. So r is equal to 15. So we have r squared is equal to 15 squared, which is equal to 225. So what do we have? X squared plus y squared, let me just wait on that 225 and put it here, is equal to 225. So here, as you can see, we have a circle. And we could just note that the center is equal to 0 and the radius of that circle is equal to 15. Just thought we'd add that. Okay, theta equals 2 pi over 3. We have the tangent of theta is equal to the tangent of 2 pi over 3. Y over x is equal to the opposite of root 3. So now you can see that y is equal to the opposite of root 3 times x. And this is just an equation of a line where the y-intercept is 0 and the slope is the opposite of root 3. Whoops. See if I can make that a little bit neater. Okay, so this is a line. Okay, let's look at number 16. We have r equals negative 8 secant of theta. So we have r is equal to negative 8 divided by, or multiplied by, I'll go ahead and do the divided by. 8 divided by the cosine of theta. So r cosine of theta equals negative 8. And r cosine of theta is just x. So what do we have? We have a vertical line. X is always negative 8. Okay, r equals 10 sine of theta. So let's go ahead and multiply both sides by r. So what we would do is just multiply both sides by r. So we would have r squared. Creating that r squared equals 10r sine of theta. And so we know that r squared is x squared plus y squared. And then, that's y, equals 10y. So we have x squared plus y squared minus 10y equals 0. Now, let's go ahead and add 25 to both sides so we can complete the square. So when we do that, we come up with x squared plus y squared minus 10y plus 25 equals 25. So what we have is x squared plus y minus 5 squared equals 25. And you should recognize this, that this is a circle. The center is equal to 0, 5, and that radius is 5. And that concludes this section.